Nice progress is being made here right on the road where we live. They are paving it right now, so they're paving all this section. And either this part will be done today or tomorrow. Not sure how far along. They basically paved all the bottom part. They're working their way up. And they'll either be done with it today or tomorrow for that part. But yeah, it's moving along quite fast. That's quite nice. Cool to see. Nice way to start the week, getting paving done. Huh. Can I get the sunset? Hopefully it's on us. No idea. What's
yeah, I can see here.
You can? Oh. Here. That's better. So now we know we're in the sunset. Moon hits your eyes like a big. Okay, this is week 11. Coming to you. Week 11 documentation, Hack Reactor coding bootcamp. Throwing some B footage on the screen of an individual from their YouTube channel. What's his name? Vamos con Viomo, if I'm saying his name correctly. But he's just doing some documentation of the town I'm living in. Now, lately, I've been showing a lot of like the town I live in, but yeah, this is the town, Santa Rosa de Cabal. You're probably familiar with it if you've seen at least one episode of my documentation series, coming to you from kind of like the southwest portion of Colombia, Santa Rosa de Cabal in the departamento called Risaralda. Coming to you with yellow glasses too. I figure I'm changing up. My entire day has been viewing things with the perspective of in yellow. So yeah, side note, Santa Rosa de Cabal is known for what's called chorizo. It's a type of sausage. Sausage that's local to this area of Colombia, so they pride themselves on their sausage. With that out of the way, let's keep this video going, but I'm going to switch into a different webpage so we don't distract ourselves here, and just talk a little bit about what we did this week. This week, I'm going to let it keep playing. But this week, we had our practice test. Our practice test covers concepts on microservices, so like integrating microservices, concepts of what is Docker, how does Docker work, Docker compose files, the ports that are associated with Docker, the volumes, the images, and in addition, the front end, migrating your back end to the front end and utilizing the React web framework. And also, in addition, the Module 2 test covers solving functions with Python and JavaScript. And yeah, looking forward to Monday is the real Module 2 test, and I feel very prepared for that. I've done a lot of just additional studying and documentation to just help with grasping concepts even deeper and understanding especially what's underneath the hood. Not underneath the keyboard, but the hood. Yeah, and also this week was our real Module 2 I don't know if this guy's like a mayor or something as I'm watching this. Also was our Module 2 project with our partner that took up 5 days. So from Monday, the project was given to us and we had to turn it in on Friday. And I would say between both my partner and myself, we in total, each of us, probably put in about 40 to 45 hours maybe on the project, roughly, give or take. It was definitely time intensive, and it was a build out from back end all the way to front end, and much more than Module 1 project. And this project undoubtedly learned a massive amount of just the underworkings, and I'm very proud of just the learnings that took place this week from that, and also the challenges as far as a different type of debugging and really understanding the type of data that you're looking to send in an API request, and recognizing if it's being returned, let's say in a dictionary form or an array form, you need to make the correct adjustments based off how JavaScript operates as a language. So with that, I'm very excited going into week 12, because week 12, after we get done taking our Module 2 exam, we then work on our stretch goals or just improving on the project that we did with more creativity and more freedom from that standpoint. So I'm looking forward to seeing what my partner and myself end up working on. That being said, I just want to share a little documentation that I did for what is this thing called Docker, Docker Compose, Docker Dependencies. We need to zoom out to get a bigger perspective here. Okay, let's start with the basics. What is Docker? Well, for starters, Docker takes place on your computer, but in some ways it's not really your computer. So what do I mean by that? So this computer represents the outer box. This outer box is your computer. So either, in this case, just simplicity, you're running a Mac operating system, that's what I'm running, or you're running on Windows. There's also other ones too, like a Linux, but for simplicity, we're going to say Mac operating system, Windows operating system. Now, on your operating system, you could be running different programs. For example, you could be running VS Code, or you could be running your terminal, or you could be using a web browser like you see here, and using Chrome, for example. There's obviously many plethora of other tools you can use, but for the sake of this example, that's what we're going to use. Now, so this represents what's on your computer, your local device. Now, what we have here is what is going to be Docker. So once you install Docker, you have like your Docker desktop. You then could also run the code and do like Docker compose or Docker up. And that's what leads us to here. So in your code, you will have a Docker file. Once that is installed, it's going to have specific instructions for your project. Now, once you then run a command such as Docker compose up or Docker compose build, which allows the instructions for Docker to create a container to run on your computer, but it doesn't live on your computer, let's put it that way. So for instance, when we get to this part right here, Docker compose up, Docker compose build, it's going to create MS1. MS stands for microservice. Now this microservice is going to then be in a directory, in this case called app. All right, now we're getting that so far. I did forget to mention, but when you install Docker on a Mac, it uses what's called Linux Kit. If you do it on a Windows, it'll use WSL2. I forget what WSL stands for, but it was created by Microsoft Windows. So I imagine the W stands for Windows. Nonetheless, I don't have any experience with that because I use a Mac at the moment, but there are numerous individuals in my current cohort that definitely use Windows and utilizing Docker that way. Now, once we create the Docker file, it's going to be set up with different commands. These commands will be utilizing something called volumes. Now, volumes, just like it says here, in Docker compose the file, and volumes essentially allows you to know where your Docker file is going to be living. So in this case, microservice 1 is attached to the directory app. Now everything to the left here, in this color, it's like a lighter color, that represents your file system, your local system. Everything to the right, in this case, the blue right here, even this with these port numbers, that represents the Docker file system. It's not living on your system itself. And then you also have ports. Ports allow you to connect, in this case, like your local host port. So there's numerous ports you can set up. But in this case, you set up 3000, port 3000. I think less the colon, this represents on your local device. So if I just like open up my web browser right now and I type in localhost 3000, it's not gonna work, I don't have anything running. But that's what would take me to that page that I programmed, in this case, to show up in my Docker file for commands. Now, once I'm running this, it allows me to connect with these directions. So for example, 80 represents the Docker container. So that's what this symbol represents. Port 80 allows me to utilize this microservice that's running on the Docker container and then connect to my local system on port 3000 into my browser, in this case, to return HTML. It also allows my microservice on my container to talk to my microservice that's living on my local device. And the cool thing too is like you add another microservice building the container in Docker, and that one can talk exactly through the same port as your first microservice, one in this case, works. So that's just a little bit of Docker. Let's move on because I got crazy today with doing some diagrams on Excalidraw, and I would like to review them, and that's what we're doing. So now we're moving on to Docker and Compose. You can think of like Docker and Compose as like the blueprints for instructions. It's instructions for once you are doing Docker Compose up or Docker Compose build. It's the instructions and blueprints of how everything is going to connect. So with that said, this is what an example Docker Compose file would look like, could look like. You're going to have 4 different servers that you are programming in this case. Django app is one, React app is another, PG is another one. PG, in this case, is like our database for this example. Postgres database, and RabbitMQ is like a messaging service. Okay, so when we run this, this is like a diagram I made for, to the left represents our local computer, and how it's going to interact now with your Docker containers. When you run this code, you're going to be building 4 different servers, 4 different containers. Now these containers, first one, Django app. It's going to create a Django development server. Now here on ports 8000, this is letting your computer know and the containers know that the only way your local device and the containers are going to communicate is through port 8000. That's what 8000. I could actually switch this number too, but in this case, everything to the left, the colon represents local, everything to the right represents the container. So 8000, 8000. Okay, so that's where this comes in. So my Django app 8000, it's running on port 8000. It's going to connect with my local device on port 8000. Same for my PG, which is my database, and in addition, my RabbitMQ 8000. So they're all going through the same port that way. Now my React server was set to 3000, and that's where you're going to see it right here, React development server 3000. Boom, that's how it's connecting to my local computer. And anytime I type in a web browser, like this case, this would open up that React app the way I typed that into the browser. Now, another thing I want to mention is this app itself, Django app, will not start until the PG and the RabbitMQ start. It's like the Docker Compose dependencies. So this app itself depends on PG and RabbitMQ running correctly. So upon doing this at first, you're going to see, I guess it's down there. I put it all the way over here. I guess I'm jumping ahead. Yeah, let's just go to that. Why not? So the Docker dependencies. So like I was saying, the Django app's not going to start until your PG and RabbitMQ start. Then the Django app will fire up, and the React app will actually just start on its own because, well, you also have to run the code command npm start, but there was no dependencies given whatsoever. And also when you're creating images, I know I didn't really mention this, but when you are creating images, you can program that into your instructions here and type in a pre-existing image with the correct command. In this case, we're running a node latest version, and these images that do already exist, they exist on the hub.docker.com. So that's Docker's own database. It stores images that allow individuals to access those images to thus save a lot more time for developers. So a shout out to previous developers and saving other developers time. I really appreciate every individual there. Let's also go into what is Docker Compose, the filing that exists. So when we add these instructions, you'll notice we have context, we have a volumes backend, we have volumes frontend, we have volumes data. This is like how the filing system works. So when this gets created, this is my project on my computer. It's going to have a backend folder. It's going to have a front-end folder. It's going to have a data folder. Now, each one of these are going to be parents. They're going to be parents to other files. So my backend, I'm going to have generated like a Docker file. I'm going to have a manage.py file. And then this is on my local storage, right? And then when I'm running this container, or when I'm running this Docker container that has other containers, it's going to have those files duplicated. Which is cool. That's a good thing. Yeah. I do wonder later on in the future, if doing like a much bigger projects, just the effectiveness of doing Docker itself. Because I know there's something called, starts with a K. I mentioned it before in a video several weeks back. Kuber something. I know Google has a service. There's other services out there too, but it helps with really widening your ability to share your application on a much larger scale. Kubernetes, Kuber something. It's Kuber something. That's what's coming to mind. But that's a bit more on Docker itself. Let's see how the video has progressed. It looks like this individual is now finishing up in the tamales, so that's pretty cool. Highly recommend when you get a chance to come to Colombia to search out for activities that involve the hot springs. It's not just this in this area of Colombia that I'm in, but there's also numerous other areas of Colombia. And by the way, Colombia, from what I understand, I remember I learned this a couple years ago, but I'm sure it's still the case. If not, it's in the top 10 at the very least. But I learned it was like the number 2 most biodiverse country in the world. If nothing else, it's one of the most biodiverse areas of all of the world, in line with Brazil, because I think Brazil is number 1. But yeah, that was just a bit about week 11. To finish up, let's dive a little bit into a project, an idea I had. I think it's probably been done before, but I didn't look into it to see if it's been done before. But I'm excited nonetheless to, it's kind of like my first idea I've had when it comes to like a project without any other like prior, somebody already did it, to follow them. So the idea is, because we built basically like a car database website, not a car database website, but just a car dealership website for our Module 2 project. Now my idea is, because I've been really getting into artificial intelligence and like technology with that, is I want to have the ability to upload a picture on the website. So in this case, we upload a picture of like a Hummer, right? And then in my application, once the picture has been uploaded, it's instantly going to return information of the price point for that car without even you having to tell what the year of the model or any other information. It's just a picture of it, okay? I know I can do it. But so far, I've written this code and I created like an account on Google Cloud platform, and I'm accessing like a specific AI API they have called, I think it's just like Google Cloud AI API, something along those lines. But anyway, I built this yesterday with this code, and upon doing this, what I have so far, it's very like rough, like there's not much to it at the moment. But when I run this code with this picture, and I can pick a different picture too, I get back in my return statement descriptions of what's in this picture, because I'm using like an AI API that has a set amount of model of pictures and associating like words and descriptions with those pictures, which is pretty cool. So when I ran this code, like I have down here, it's saying I get back descriptions, label descriptions. So I get back wheel, automated parking light, well, wheel, tire, car, land vehicle, vehicle, hood, grill. Those are like already pre-generated descriptions just from uploading this picture, which is pretty cool. So my next phase of this project is like tomorrow and Tuesday to do like, because I found like a data set. I found a data set that allows me to train a model that I can do on Google Cloud Platform, learning as I'm going though. And when I train that model, I know one of the models or database I found has like 200,000 images on a GitHub repo. But I think let's see if I can find it right away. It was in a GitHub. Yeah, it was this one right here. So this GitHub, which actually hasn't been updated in a long time, since 2020, but it already has a pre-trained model of, consisting of 291 plus thousand images covering models manufactured between 1950 and 2016. And that's what I need. And I think there's a couple other ones I found too, but I don't know if I can, in my week time of figuring out this project, if I can figure that out. But I think I can. If nothing less, I'm going to see what I can do. But I take this data set and I upload it into like different buckets, I think that's what it is, in my Google Cloud Platform account, and I'm able to train a model that can recognize pictures of models and years and return that. And then I'm gonna have to find how to connect that to like a price database of these cars. But that's what I'm working on this week. I'm really excited. So to sum up, week 12, starting tomorrow, got the Module 2 test, so feeling really good about that. And just continue on with our partner project for the rest of week 12. It's a shorter week, so we do get the Friday off. And then that following week, which would be week 13, on Tuesday, my girlfriend and myself were flying to New York City for just 4 days for a conference that she's working at. And so I'll be doing coding work, software engineer work, artificial intelligence work, just studying technology, just being productive from there. So with that, I'm going to sign off for now. Xander with the yellow glasses, just for now. I'm sure I'll come back to you again with a different set of glasses. And yeah, love and life. Keep it on trucking, keep it on doing, and keep it on being. Much love. Thank you so much for watching. As always, if you have any questions, comments, or feedback, send them my way. More than happy to reply and take the time. Really appreciate it so much. Nos vemos en mi próximo video. Muchísimas gracias por tu atención. Ciao, ciao for now. Peace.